Alright, so tri means three, gon means angle, and metry means the geometrical properties applied to geometrical figures with three angles. That is triangle. The first category of triangles is equilateral triangle, that is all sides and all angles are equal. The second category of triangles is that two sides and two angles are equal, and the third category is none of the sides and none of the angles are equal. Then the last three categories are based on angles. Acute angle triangles means all angles are less than 90 degrees. Obtuse angle triangles have one angle greater than 90 degrees. And right angle triangles have one angle which is 90 degrees. Now, let's say for example we have this. This triangle has one angle greater than 90 degrees, thus is obtuse and has two equal angles, that is, it is also isosceles. Then we have this triangle. All angles are less than 90 degrees, thus this angle is acute, this triangle is acute, and this has two equal angles of 50, thus this is also isosceles. Then we have this, where all angles are different and all angles are less than 90 degrees, thus this triangle is acute and scalene. You guessed it right. Then we have this triangle 80, 40 and 60. All angles are different, thus is a scalene triangle, and all angles are less than 90 degrees, thus this is an acute angle triangle. Let's say if we have this 190-degree angle, thus this triangle is right angle, and we have two angles of 45 degrees. Thus this triangle is also an isosceles triangle. We have this too. We have 190-degree angle. Thus this triangle can be classified as a right angle triangle. And then we have 30 and 60. All angles are different. Thus this is a scalene triangle as well. And finally you have this. All angles are different first of all, and one angle is greater than 90 degrees. Thus an obtuse angle triangle as well. So now you guys should appreciate the fact that there is always an overlap between the categories. There is always an overlap between the categories. Thus, triangles are often broadly categorized only as right angle triangles and not right angle triangles. When we talk about right angle triangles, we will talk about Pythagoras theorem, that is hypotenuse square is equals to perpendicular square plus adjacent square. Similarly, we will also talk about the area, half base into perpendicular height, the trigonometric functions of so, ka, twa. And we will talk about these three things in future class. And you also learned most of these in AS level, but when we talk about trigonometric identities, this chapter does include new identities. Then we have non-right angle triangles, sine rule, cosine rule, and the area of non-right angle triangles, which I expect you have also studied, but we will recap them. So let's say we have these two right angle triangles. Now, essentially, what is the hypotenuse? What is the perpendicular? What is the base? It's based on where the angle is located. For example, in this case, the angle is located here. So this side will be the opposite. This would be the hypotenuse, and this would be the adjacent side. I'll talk in terms of of hypotenuse, opposite, and adjacent. You can also call the opposite the perpendicular and the adjacent the base. Similarly, we have this. The side the side opposite the angle is the perpendicular or the opposite. This side would be the hypotenuse, that is opposite the right angle triangle, and this side is either the base or the adjacent. Alright. So these are the three trigonometric ratios which you started to learn earlier in middle school or grade 9. And the mnemonics to remember them is, if you are using the terms perpendicular and base, you can remember the ratios as some people have curly brown hair till painted black. Or the easier method is to remember these ratios as so katwa. That is, you will use the terminologies of opposite and adjacent and hypotenuse means the same. So let's say for example we have this. We need to find the hypotenuse and the angle. So first of all, let's start with finding the hypotenuse. Let's call this h as label. We have 4 square plus a 3 square. H is root of 9 plus 16, thus h is root of 25 and h is equals to 5. Now the angle. For the angle, since we have all three sides now, we can use either of the trigonometric ratios. First of all, let's use sine, that is sine theta is equal to opposite over hypotenuse. This is the opposite, this is the hypotenuse, which we found here. Thus, we have a 4 over 5. When you put this in your calculator, you will have something like theta is equals to sine inverse of 4 over 5. This would turn out to be 53.13 degrees. Similarly, if you use cos theta, that is adjacent over hypotenuse by so ka twa, and you can also use tan theta, that would be opposite over adjacent. So cos theta would be 3 over 5 and tan theta would be 4 over 3. So using inverse of, that is cos inverse of 3 over 5, the angle turns out to be the same. Then again, what if we use tan inverse of 4 over 3? The angle would again turn out to be the same. Thus, whenever you have on three sides, it does not matter which ratio you use, the angle will always turn out to be the same. And since we have all three angles, we can find the area as well, which would be something like, an area is given by half base into height, and in this case the height is the perpendicular height. So area is half into 3 over 4, half into 3 into 4. This would give me an answer of 6 centimeter square. This we are talking about area. Then our second example is this. We need to find the perpendicular and the angle. So in this case, we have hypotenuse is equals to opposite, just a second. Oh, the opposite is labeled as p. Thus we have a p square and the base, that is 5 square. We'll simplify this, and P turns out to be the root of 144, and P thus turns out to be 12 centimeter. Then again, we can use either of the trigonometric ratios. Sin theta in this case would be 12 over 13. Similarly, cos theta is adjacent to our hypotenuse. That would be this. And tan theta is equals to 12 over 5. And the angle from all three of these ratios turns out to be 67.14 degrees. When you talk about angle in degrees, you should preferably leave them in three significant you should preferably leave them to one decimal place, but when we talk about angle in radians, leave them to three significant figures in your exam. Then once again we can find the area in this case too. So area is equal to half into 5 into the opposite, which we found as 12 centimeters. Thus area is equals to 30 centimeters. Then we have this, where we have to find the base. We'll use Pythagoras theorem yet again. So 25 square, that is the hypotenuse square, is equals to base square plus opposite square. Simplifying this would give me 576 root, and B turns out to be 24 centimeters. Alright, let's go to. And let's say the three ratios I have in this case are sin theta, cos theta, and tan theta as always. Sin theta in this case is 7 over 25. Cos theta in this case is 24 over 25. Tan theta in this case is 7 over 24. Solving all three ratios would give me the same answer of the angle, that is 16.3 degrees. Then finding the area. Half into 7 into 24. So half into 24 into 7. So 12 into 7 is 84 centimeter square. That is the area. Then we have our fourth example. We are given all three sides, since I only wanted to test the fact that what if we change where the angle is, and we need to find angle in this case. So this 6 centimeters would be considered as the opposite side. This 8 centimeters would be considered the adjacent side, and the hypotenuse is always the side opposite the right angle triangle. Thus, once we determine the opposite hypotenuse and the adjacent, we can form our trigonometric ratio. Sin theta is 6 over 10, cos theta is 8 over 10, and tan theta is 6 over 8. Theta turns out to be 36.9 degrees from all these ratios. And if we want to find the area of this, it's half into 8 into 6, and 8 into 3 is 24 units, or rather centimeter square, since the units are given. If the units are not given, write units